Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science 2023 Chemistry Paper 2 Foundation Tier. Question number 6 is on the topic of chemical analysis. Chromatography is used to separate mixtures. Now, chromatography is a required practical. And they have asked questions about chromatography at least 3 times in the past couple of years. So you should make sure that you are revising the topic on chromatography. So what is the other phase in chromatography? Chromatography dissolves in mobile phase and one other phase. Mobile phase is the moving phase, right? That is basically the liquid part. And other phase, what is the other phase? Well, you don't call it the moving phase. You could be calling it moving phase. But moving phase and mobile phase is more or less the same thing. Recycle phase, no. Stationary phase, that's correct. Right? So there's two phases where one part of the chromatography at the start is stationary and then it's moving. Why does the substances in the mixture separate in mobile phase? Why do the substances in the mixture separate in the mobile phase? Mainly because they move at different speeds, right? So from one dot, all the different mixtures, for example, in ink, if you're using chromatography of ink, from one dot, you'll get all the different colors. That's mainly because all the different colors in that one dot are moving at different speeds, so they spread out. How many spots will be produced from the chromatogram of a pure compound? Well, if it's something pure, you're only going to get one. So the number of spots will be 1. If it produces a single spot, that's how you can verify that it's actually pure. In a chromatography experiment, a blue color moved 4.77 centimeters. The solvent moved 5.3 centimeters. Calculate the RF value for the blue color. Now, RF values are calculated by dividing one of these numbers by the other, right? And here it's 4.77 divided by 5.3. Now, the bigger number, the solvent distance moved is always at the bottom, whereas the solute moved should be on the top. And so when you get 4.77, let's bring in the calculator. 4.77 divided by 5.3 gives you 9 over 10, which is 0.9. So 0.9. Now there is no units for it, so it's just simply a number. And always remember the RF values, right? When you are calculating the RF values, right? RF values are always less than 1. So if your answer is 1 or more than 1, then usually that means your answer is wrong, definitely, and you have divided the numbers in the wrong order. Question 6.5. Black ink is a mixture. Black ink is a mixture of several colors. Plan an experiment using paper chromatography to separate the colors in the black ink. Identify the colors from their RF values. So how would you do it? Well, before you start writing, it's much better to actually draw a really simple diagram. So how would you set it up? First, you get the chromatography paper. Let's say that's the chromatography paper. Use a ruler and draw a pencil line, right? In pencil, that's important that you mention that it's a pencil line. Line drawn in pencil, not in ink. And then you would put the black ink, right? So let's see, right? You put it there, right? And you put dark, one spot of black ink on the paper. This is the chromatography paper. So it's usually, there's different types of chromatography paper. We in class or in the school labs, to separate out ink, we generally use filter papers. Okay? And then what do? Well, then you take a beaker and fill it with water. Not fill it with water, fill it with just about 1 centimeter with water. Then you take a pencil or a wood splint so that it actually goes on both sides. And then you take this filter paper and put it so that it's actually just touching the water. Right? It's just about there. Right? And you would secure it on the top with a paper clip. And the ink dot should be just above this water. So that pencil line should be something like that. And the ink dot shouldn't be touching the water. That's important. Right? If the ink dot touches the water, then you got it wrong. Now, if you can actually draw this and label this, then you are going to walk away with at least 2 marks. Right? So it's always better to have a simple diagram as part of your answer. So if you were to actually set it up, this is what it'll actually look like. So you've got the beaker, right? And now this diagram, the reason I didn't show this before is because this diagram is not entirely correct. And because you can see the ink spot, the solvent, and it looks like after the solvent level is right over here. So which is actually wrong. So the solvent level should be somewhere there. At the start, you would have one spot of ink, and then at the end, you should have all the different colors separated out. Now, the way you work out the RF value is find the distance from the solvent front to the origin. Right? Find the distance of solvent. And let's say you want to find the RF value for the yellow color. So you, from the middle line, you draw a line and then basically measure the distance between your pencil line and this, right? So what did they call it? So solvent and color, right? So pigment distance. So RF value is pigment distance or color distance over solvent distance. Right? So again, if you mention the equation and how on the diagram, if you actually drawn this and labeled it correctly, then you should get another 2 marks. So getting 6 marks for this question is not very hard. So So here's a sample answer how you could actually write it. I know there's about 13 steps here, but I've just broken it down. And this is why writing a drawing actually helps you to avoid having to write it, because a lot of these bullet points that I'm showing you here, you don't really have to write it if you draw a label diagram. So first thing, draw a pencil line near the bottom edge of the chromatography paper. That's in the diagram. So if you draw it, then you can avoid having to write it. Put a small dot of ink in the pen, dot of black ink on the pencil line. Again, it's shown in the diagram. Put a small volume of water or solvent in a beaker in the diagram. Place the chromatography paper in the solvent. The dots of ink should be above the level of the water. So you have to mention it here if you don't write it, or if you haven't clearly shown it in the diagram. Support the paper in this position. Put a lid in the beaker and leave to run. Mark position of solvent front. Right, so they're placing a lid on the beaker so that the water doesn't evaporate off, or the solvent. Mark position of solvent front, meaning the leading edge of the liquid. Remove from beaker and leave it to dry. Determine RF values by measuring distance of all dots from the start line. Measure distance of solvent from the start line, and then calculate the RF values for all dots. Again, they're not asking you to mention the equation, but it's better. Compare with known RF values. Again, draw the, if you get a question like this, right, from 2023, so it's been last year, don't know if they did actually ask a question. So if they did ask a question, you would actually draw a label diagram, and then you can simply start off by saying, set up the equipment as shown in the diagram. That's the best way, and then you could focus your answer mainly on how you get the RF values. But if you draw a label diagram, you should definitely get at least 3 marks, definitely. That brings us to the end of the video and the end of the question as well, and that's the last question in this 2023 chemistry paper. Thanks for watching. All the questions are in a playlist, so if you want to watch any of the other questions from question 1 to 5, always click on the playlist. If you want to try out and answer the question on your own, there's a link for a forms quiz in the description. If you like this video and found it useful, always hit the like and subscribe button. Thank you.